Hi, this is June 15 AQA C3 paper. Again, pause it, have a go at the question and then have a look at my workings and we'll see where we are. First things first, there's a number of different ways you can do it. The easiest is to try and get something equaling 0. So if you see these two equations are both y equals, so you could make them equal to each other. Okay, and then make it so that you've got 0 or f of x equals or 0 equals. So I'm going to make this 0 equals. Am I going to do it that way? Yeah. No, I'm not. I'm going to go the other way. Okay, so I'm going to go 6 ln x minus 8x plus x squared plus 3 equals 0. I'll go that way round. Okay, then I'm going to shove in the two different values of x. So they're telling us 5 and 6. So when x equals 5, I get out the answer minus 2.3. When x equals 6, I get, and I would show it all, to be honest, shoving it all in, you get the answer 1.75. I'm not, just because I haven't got much room. So at that point then you get your two different answers. There's a change of sign, so you actually have to write change of sign. So therefore 5 is less than alpha is less than 6, meaning your solution must lie within those two values. Okay, so then it says show that this equation up here there we go. Give myself some writing space. Okay, so show that this equation can be rearranged in this form. Whenever you are trying to solve different things, you can't just, and when people have done this, loads of people seem to like writing this. This is completely, absolutely wrong. Okay, if you learn or square anything, you have to do the same thing to both sides. You can't do it to individual terms. So for example, if we have 3 plus 4 equals 7, you will find out that 3 squared plus 4 squared does not equal 7 squared. It's just impossible. So you have to do that. And that makes so much more sense, doesn't it? So it's complete rubbish. The same goes for when you learn things. You have to learn the whole side of the equal sign. You can't just decide to do little bits. You have to do the whole thing. So in this case, the first thing you've got to do is bring that 4 over to the other side. Okay, then you can square both sides. Then you need to multiply out this side. I would do it properly, longhand, given you have the time. Okay, and then obviously if you're looking at the equation of where you want to go, so I'm going to bring the 6 ln x over this side. I've got my plus x squared, I've got my minus 8x, and I've got plus 16, and I'm going to take away that, which gives me plus 3 equals 0. Awesome. Done that bit. Right, I've changed the page now, and we'll have a look at using the iterative formula. Which is quite straightforward. I think most people get this right. So you're literally going to shove in, I keep shoving things, in here x is going to be 5. So when x of 1 is 5, x2 is going to be 4 plus the square root of 13 minus 6 ln 5. And you get the answer of 5.828 as long as you round it correctly. And then for x3, you're going to do 4 plus square root of 13 minus 6 ln, and whatever that answer was, 5.82, blah, 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 blah. Do not round it. And you get the answer 5.557 when you round it to the 3 decimal places they were after. Okay, that's that one done. Next one. A curve has this equation, blah, blah, blah. Find the exact value of the coordinates of the stationary points. So back to C1 and C2. Stationary points is where your differential, your dy by dx equals 0. So we're looking for where f dashed x, in this case, equals 0. So we need to differentiate that. So f dashed x equals 6 times ln of x Differential of ln of x is 1 over x. 2x minus 8, and then the constant ends up as 0. All good. So that's 1 mark. Where it equals 0 then, I'm going to go down here. Actually, I could pull that up. There we go. So where it equals 0, you tell 0 equals 6 over x plus 2x minus 8. There's another mark to show that you know what you're doing. And then the next mark comes from solving it. So you're going to multiply through by x, which is 6 plus 2x squared minus 8x. And then you obviously need to solve that. And it's probably easier if we simplify it. Oh, because the bigger the numbers are, the harder they are to work out. Which leaves me with x equals 1 or x equals 3. At that point then, it does ask me for the stationary points of the curve, so I'm going to shove in my x equals 1 into the original formula, and I come out with y equals minus 4, and this one I come out with 6 ln of 3 minus 12. Okay, and now for the last bit, find the exact values of the points of the curve. So we've done that. So then the very last bit, which is under here, so I'll just get rid of some of this. So we've got our 2 solutions to the right there, and now what they want us to do is transform them. So hence or otherwise. Now I would always try and go for hence, because you've obviously done something if they say hence. So hence, you want to do that, which means your x value will be adding 4, because that's an inside transformation. It affects the x, you're going to add 4 to the x's, and your y's are going to be doubled. So I reckon your new term will be x is 5, and which means y is doubled, which is minus 8, and x is add 4 is 7, and y is double gives you 12 ln 3 minus 24. Hopefully that is correct, which it is, which means you got that bit right as well. That's question done.